Hi dear students, this is Viscosity, Assistant Professor, Department of Chemistry, Arts, Commerce and Science College, Java District, Palghar. Dear friends, in the previous part of the videos, we have completed the topic chemical kinetics from the unit number first. In the chemical kinetics, we have discussed about the different concepts like order of reaction, molecularity of reaction, rate law, first order, second order reaction, speed order reaction, and the different methods for the determination of order of reaction. Dear friends, in the 11th and the 12th, you might have studied about the different states of the matter like the solid state, gaseous state. Here, in this part of the video, we are going to talk about the another state of the matter entitled as liquid state. As far as concerned with the liquid state, the physical properties and the measurement of physical properties like surface tension, viscosity, refractive index of liquids is having much more importance because these are used in the study of composition and the structure of the molecules. And now we have more suitable techniques for measurement of these properties in order to study the structure of molecule like spectroscopic methods. The various physical properties based upon the measurement or based upon the physical property or based upon the measurement, the physical properties of substances are classified into two types called as additive properties and the constitutive properties. So these are the two types based upon their measurement, how the properties are measured, and then these are classified as additive properties and the constitutive properties. So additive properties are the properties which are obtained by adding the or by taking the sum of corresponding properties of all the constituent atoms present in the molecule. Here this is very important. Whenever the property of substances are obtained by taking the sum of the corresponding properties of constituent atoms in the molecule, then the property is called as the additive property. For example, suppose we will talk about the molecular mass or the weight of an atom does not change, and molecular weight of the substance can be obtained by taking the sum of atomic weight of all the atoms present in the molecule, and that's why molecular weight or the molecular mass is called as additive property, because it is obtained by taking the sum of, hence this molecular weight of the substance is called as additive property. Similarly, the molecular heat of compound is the sum of atomic heat of atoms present in the molecule. That's why molecular heat is also called as additive property. The another property is called as the constitutive property. Dear friends, here word itself indicates this constitutive property depends upon the constitution of the molecule, how the atoms in the molecules are constituted, these are arranged. Based upon their arrangement, the properties depends, and this property is called as a constitutive property. It means that this property depends upon the arrangement of atoms in the molecule, and then this property is called as the constitutive property. For example, the optical activity is the constitutive property because the optical activity of the molecule depends upon the presence or the absence of asymmetric carbon atoms in the molecule. That's why, as it depends upon the constituent or the arrangement of atoms in the molecule, means it depends upon the asymmetric carbon atoms in the molecule. That's why it is called as a constitutive property, and this property is purely constitutive. Optical activity is purely constitutive property. But dear friends, there are some properties which are partly constitutive and partly additive. These are very important. Means these are the properties which depends upon the sum of corresponding properties also of all atoms, as well as arrangement of atoms in the molecule also. And these properties are like viscosity, refractivity. These are partly additive and the partly constitutive. So this is very important. Such type of the questions can be asked to you in the MCQ, whether this is additive, constitutive, partly additive and partly constitutive. So definitely these are both partly additive as well as partly constitutive, like the properties of viscosity and the refractivity. Dear friends, as far as concerned with the liquid, we will talk about its first physical property, and that is called as surface tension. So this surface tension, how the surface tension is arised in the molecule, how the liquid molecule shows the surface tension. This is again very important. And here, whenever we will talk about the nature of liquid molecules, then we will come to know that the molecule in the interior part of the liquid is completely surrounded by other liquid molecules from all the sides, and hence, on an average, it is attracted equally in all the possible direction. And however, the molecule which are present at the surface of liquid is subjected to a only resultant inward pull, because this molecule is having the greater force of attraction from the downward direction. So it shows the inward pull in the downward direction, and because of this inward pull, the surface of liquid tends to contract to the smallest possible area and behave as if there is a state of tension. So here you can see these are the molecules which are present at the surface, and these are the molecules which are present in the bulk or inside the liquid. And then you will come to that this molecule which are present in the bulk of the liquid, this molecule has force of attraction from all the direction. This molecule has force of attraction equally from all the direction, and that's why the net force acting on these molecules will be zero, and that's why these molecules are in a state of equilibrium. But whenever we talk about the molecules which are present at the surface of liquid, then you will come to that then there is a nothing at this above on the above this molecule, and that's why this molecule has a force of attraction, cohesive force of attraction only from the downward direction, and that's why all these molecules are pulled in the downward direction, and that's why this molecule behave as if it were in a state of tension. And this explains why the small amount of raindrop or the UU mercury has a concave shape. So this is very sort of say spherical shape, and this is the tension. And this sphere has this because these are existing in the sphere, and this tension produced on the surface of liquid, which pulled to the side of liquid in the downward direction, is called as surface tension. This is the reason why the surface of liquid always shows a surface tension, and the surface tension therefore can be defined as the force in a Newton acting along the surface of liquid at right angles to any line 1 meter in length at the surface of liquid is called as that force in Newton acting along the surface of a liquid at right angles to the line of 1 meter in length is called as the surface tension. If we'll talk about the unit or the measurement of this surface tension, then the SI unit of surface tension is always, as it is the force acting on the line on the area, that's why it is the SI unit of the surface tension is Newton per meter. Again, the question arises, how can we calculate the surface tension of the particular liquid? Actually, I will say it is the comparative property, not an exact property. So determination of surface tension is involving the method, and that method is called like the drop number method. Actually, what name is given based upon the counting of the number of drops from the particular volume of the liquid. That's why it is called like the drop number method. Dear friends, if we talk about this method used for the determination of surface tension of a particular liquid in detail, then you will come to that if you will talk about this method in detail, then you will come to that the surface tension of liquid can be determined, can be measured with the help of instrument called as drop stalagometer. Dear friend, this name is given based upon the name of scientist who has discovered this instrument. And in this method, the number of drops formed from the fixed volume of liquid between the two marks is determined, and this method is called like the drop number method. Actually, the lower portion of this is the diagram that indicates the stalagometer. The lower portion of this stalagometer having the two marks A and the marks B, And definitely uh, in this mark also there is a fine capillary, and the upper portion is connected by rubber tubings to the Y-shaped glass tube. So at the start, what they have given the two parts here, one is the pinch cock and the another one is the screw clamp. The screw clamp is used to adjust the flow of liquid, and pinch cock is used to suck the solution inside this stalagmometer. Dear friends, at the start of the process, the screw clamp is closed and the given volume is sucked into the stalagmometer to a level above the mark A by opening the pinch cock. The pinch cock is then closed and the screw clamp is gradually opened so that the number of drops flowing out in between 15 to 20 per minute. So initially the rate of flow of liquid in terms of number of drops is adjusted with the help of the screw clamp, and once this drop rate in between 15 to 20 per minute is achieved, the screw clamp is left undisturbed, and the liquid is then again sucked in by using the pinch cock without allowing any air bubble in the capillary, and then the number of drops formed between or formed while liquid flows from mark A to mark B is then determined, and let this number is denoted by N1. So N1, these are the number of drops formed from the volume of liquid between mark A and the mark B. So this is the important thing. And if 2 pi r gamma 1 into cos theta is the force due to surface tension on a single drop, then the force on N1 drops will be 2 pi r gamma 1 into N1. This is very simple. This is the force due to a single drop, and force due to N1 drop will be 2 pi r gamma 1 N1 into cos theta. Later this force have to be balanced by the weight of N1 drops, and this weight is m1 into g. m1 is the mass of N1 drops, and finally we are getting the equation. These two forces are unequal, then there is a formation of drops. 2 pi r N1 gamma 1 into cos theta. This is the force due to surface tension on N1 drops, and this is the weight of N1 drops m1 into g. But do you know very well mass per unit volume is the density, and therefore mass can be obtained by taking the product of volume into density. So finally we are getting for the liquid 1 or the liquid of this type 2 pi r n1 gamma 1 cos theta is equal to v into d1 into g, acceleration due to gravity. V is the volume of the liquid between the two marks A and B, and d1 is the density of the liquid. Dear friends, later on what happens, the stalagmometer is then cleaned, dried, and the same procedure is repeated with another liquid of surface tension gamma 2, whose value is known to us. Then the number of drops obtained with this liquid is denoted by simply N2, and definitely with the same way we are getting another equation 2 pi r gamma 1 2 pi r N2 gamma 2 into cos theta, which is equal to v into d2 into g. If we correlate this equation 1.2.2 and 1.2.1, then definitely we can equate this equation. After equating this equation, we will have this term 2 pi r. Actually there should not be 2 pi r. Let me show you something different. Actually after equating this equation, that is 2 pi r into 2 pi r n2 gamma 2 into cos theta m2 into g, 2 pi r n2 into gamma 2 into cos theta into v into d2 into g. And definitely if we here v is the volume of the liquid between the two marks A and B, and density is the another d2 is the density of another liquid. And if we divide these two equations, definitely all the terms except n1 upon n2 into gamma 1 upon gamma 2 is equal to d1 upon d2 will cancel, because here you can see this is not 2 pi will get cancelled. This r1 r2 equal this is the radius of the capillary, and as the capillary is same, stalagmometer is same, so definitely this r1 and r2 will be also same. So cos theta will get cancelled, and volume is also fixed, acceleration due to gravity will also fix, and that's why finally we are getting the equation simply n1 upon n2 into gamma 1 upon gamma 2 is equal to d1 upon d2. And finally we can write this equation for gamma 1 upon gamma 2 is equal to n2 upon n1 into d1 upon d2, and finally we can write the equation for the gamma 1 as n2 upon n1 into d1 upon d2 into gamma 2. Here gamma 2 is the density of the known liquid, gamma 1 is gamma 2 is the surface tension of unknown liquid, and this is the surface tension of gamma 2 is the surface tension of known liquid, and gamma 1 is the surface tension of unknown liquid. D1 and D2, these are counted with the help of stalamometer, and densities of the two liquids are provided. And if the N1 and N2 are determined experimentally and densities of the two liquids are given, then we will be able to calculate. What? Surface tension of unknown liquid means the gamma 1. In some books, you will find gamma 2 is equal to this N1 upon N2 into D2 upon D1 into gamma 1. Both are the same, doesn't matter, because we are going to compare the surface tension of the two liquids with the help of their number of drops and the density. So this is the way by which we will be able to calculate the surface tension of the given liquid if the surface tension of another liquid is known to us. Dear friends, another property of the liquid is very important, and that property is called as the viscosity. So here the liquid shows the resistance to some extent for the flow, and this liquid which shows the resistance to flow is known as the viscosity. So viscosity is simply the resistance for the flow of liquid is called as the viscosity. So this resistance for the flow of liquid is known as the viscosity. Actually, it is found that the liquid may be considered as consisting of number of molecular layers arranged one over the other. So it means that the liquid consists of the number of layers which are arranged one above the other, and the displacement of different layers related to one another is opposed by the internal friction, or which is also called as viscosity of the liquid. Hence, the viscosity can be also defined as the force in Newton per square meter required to maintain a difference of velocity of 1 meter per second between the two parallel layers of the liquid separated by the distance of 1 meter from each other. It's very important that how can we define this viscosity in another way, that the force in Newton per square meter required to maintain difference of velocity of 1 meter per second between the two parallel layers of the liquid separated by the distance of 1 meter from each other. And the method which is commonly used for the measurement of viscosity is based upon the Poisson's law. So this is again a much more important concept. How can we measure the viscosity of the given liquid? And the viscosity of given liquid can be measured with the help of law called as Poisson's law, which gives the relationship between the rate of flow of liquid through the capillary tube and the coefficient of viscosity of the liquid by the equation neta is equal to pi r raised to 4 into t into p divided by, in some books you will find this rho, n divided by 8 into v into L. This v is the volume of the liquid flowing through the narrow tube, r is the radius of the narrow tube in the capillary, p is the driving pressure, t is the time, and small l is the length of the tube. The unit of coefficient of viscosity means the neta is simply a poise. So this is the unit of the viscosity, or the coefficient of viscosity indicated by means of P, and 1 poise is always equal to 0.1 Newton second per meter square. So here definitely the measurement of viscosity is also important thing for the study of this physical property of the liquid, and the viscosity of any particular liquid can be measured with the help of method. This method is called as the viscosity method, and this method is also called as the Markov equation. Later this Markov equation can be used for the determination of molecular weight of the given solid also. So viscosity is useful technique. Viscometry is the useful technique for the determination of the molecular mass of the given polymer, and the molar mass obtained by this method is the viscosity average molar mass indicated by means of EMF. In this case, definitely the molecular weight can be obtained by taking the use of this viscosity of the given liquid of the polymer, and this molecular mass is called as the viscosity average molar mass. And in this case, definitely this is not the exact property, this is the comparative property, and that's why for the determination of this we are going to consider the viscosity of the two liquid. One is the pure solvent and another one is the solution of the given polymer. Suppose neta 0 is the viscosity of the given solvent, given pure solvent and neta is the viscosity of the solution of a given polymer, then the ratio of viscosity of solution of polymer to the viscosity of pure solvent is called as the relative viscosity, indicated by means of a neta R. So relative viscosity is the ratio of viscosity of the solution of the polymer to that of the pure solvent is called as the relative viscosity. And from the relative viscosity, dear friends, we are also able to calculate the specific viscosity, and this is a relative increase in viscosity. So relative increase in viscosity is called as specific viscosity, which is obtained by taking the difference between the viscosity of solution and that of the pure solvent, divide it by the viscosity of pure solvent. So this is very important, that so relative increase in viscosity is called as the specific viscosity. So specific viscosity is the ratio of increase, it is so that is difference between the viscosity of a solution and that of solvent, and divide it by the relative of the pure solvent. By taking the simplification of this, definitely specific viscosity is given by this equation, that specific viscosity is equal to the relative viscosity minus 1. So reduce, and from this specific viscosity we are also able to get the value of reduced viscosity, and this reduced viscosity is the ratio of relative increase in specific viscosity per unit concentration. It means that this specific viscosity, whenever divided by the concentration, we are getting the reduced viscosity. It's very, very important. So all these things are much more important, and this reduced viscosity depends upon the molecular weight of the given polymer, and as reduced viscosity depends upon the concentration, it is necessary to extrapolate the plot of specific viscosity to the concentration versus under root of concentration, or to the zero concentration, and this value is called like the intrinsic viscosity. So whenever this graph is extrapolated to zero concentration, then that value is called like intrinsic viscosity. There definitely we will see this later, but how the molecular weight can be calculated with the help of this Markov equation, this is also the important part of this study. So for this purpose, dear friends, we will consider a fixed volume of the liquid flowing through the capillary of radius r and the length L in a time t second, which is related to the absolute viscosity by the Poiseuille's law, and according to Poiseuille's law, this coefficient of viscosity is related to the flow of liquid, definitely p pi r raised to 4 into t divided by 8 into v into L. So we will write this equation for the flow of time t, 8 into neta into v into L divided by p pi r raised to 4. P is the pressure difference under which the liquid flows, and neta 0 are the as the viscosities of polymer solution and that of pure solvent respectively, having a flow times t1, t and t0 through the same capillary tube. So we write this equation for t0 also, definitely their viscosity will be neta 0, and definitely we will correlate this equation number 7 and the equation number 8, that is 7 divided by 8, we will get this equation theta t upon t0 is equal to neta upon neta 0. It is also noted that for the calculation of this intrinsic viscosity of the given polymer solution, it is not necessary to know the absolute viscosity of the pure solvent and the solution, but by using the Austrol viscometer, only the flow times of constant volume of solvent and the solution through the particular capillary tube is determined, and the specific viscosity of the solution of the polymer of different concentration in a given solvent is determined, and the ratio of specific viscosity to concentration is plotted against concentration, and the graph is extrapolated or extended to zero concentration. So when the ratio of specific viscosity to concentration is plotted against the concentration of the graph is extended to zero concentration, then this value is known as intrinsic viscosity. So dear friends, you can see here the specific viscosity versus divided by concentration is plotted against the concentration, and in this way we are getting the straight line. But if this straight line is extrapolated to zero concentration, then it gives intrinsic viscosity. So this y-intercept is called as intrinsic viscosity. This intrinsic viscosity of polymers is related to the molecular weight by the Markov equation, that intrinsic viscosity is equal to k into m raised to alpha, This K and alpha are the constant, and this value can be determined by measuring the intrinsic viscosity of series of sample solutions, which is the molecular weight of have been obtained. The value of log of intrinsic viscosity whenever plotted versus the log of molecular mass, it gives a straight line having the slope that alpha, and the y-intercept will be log of k. So here for the determination of values of this constant, we have to plot the graph of log of intrinsic viscosity versus log of molecular mass, and in this way we are getting the straight line. And again, if this straight line is extended to zero concentration, then the y-intercept indicates the log of k, while the slope of this line indicates the another constant alpha. In this way we are able to calculate the value of k and alpha. Later on, with the help of this k and alpha, definitely we will be also able to calculate the value of this m. So dear friends, in this way we have discussed about the two important physical properties of the liquid state. One is called as viscosity and the another one is called as the surface tension. And at the same time we have discussed about the how this can be calculated with the help of a particular experimental method. So this is the important thing. Dear friends, in the next part we will talk about the determination of viscosity by Ostwald viscometer. So we will resume in the next part of the video to discuss about the determination of viscosity by Ostwald viscometer. Thank you very much.